our Pythagorean theorem and distance formula quiz review. Let me fix this. Hold on a second. That's going to be sensitive. So hopefully this will stay on the whole time. Here we go. All right. So right off the bat, I'm just going to go ahead and write out a squared plus b squared equals c squared. And that c is the hypotenuse. And the best way to remember this is just the legs are the ones that form the 90-degree angle, right? They're the ones that meet at the 90-degree angle. The hypotenuse is across from that 90-degree angle. So here for number 1, I know A and B. I know these two sides that form this 90-degree angle here. So that's what I want to put in as the A and the B. I've got 14 squared plus 12 squared equals, and I'll just leave the hypotenuse as a c. That's my variable, okay? So that's this side right here. 14 squared we know is 196. 12 squared is 144. Right, so all I'm doing is just solving this equation for c. And to do that, I'm going to simplify first. And this is what I'm doing. So I've got 196 plus 144, and that equals 340, which equals c squared. And then we know to undo that exponent of 2, to undo something being squared, we take the square root. So I will take the square root of both sides. And the square root of 340, if I round to the nearest tenth, is 18.4. Okay? So I've got the hypotenuse for that one. For number 2, they give us the hypotenuse. That's this one right here. Okay? And they give us one of the legs. So we need to solve for the other leg. I'll say that other leg is A. All right? So I've got A squared plus 9 squared equals 14 squared. Okay, a squared is going to stay the same. Now I'm just solving this equation, and the first thing I'm going to do is simplify. 9 squared is 81. And 14 squared, we just did that in the other problem, is 196. So I'm going to subtract 81 from both sides, and I get a squared equals 115. And then I know to undo something being squared, we just take the square root. So I'll take the square root of both sides. When I take the square root of 115, and I round to the nearest tenth, that's what my directions say, it is 10.7. Okay, and then that's all I'm doing for the rest of these as well. Okay, putting in what I know. In this case, I know the hypotenuse again for number 3, and I know one of the legs. I'll label this one A again. So I've got a squared plus 4 squared equals 6 squared. And remember, these legs are interchangeable. It doesn't matter which one is A and which one is B. Okay. Simplify. I've got a squared plus 16, because 4 squared is 16, equals 36. 6 squared is 36. Well, subtract 16 from both sides. We get a squared equals 20. And then to undo that square, take the square root. When I take the square root of both sides, I get second square root of 20. I round to the nearest tenth. It's going to be 4.5, 4.5. It's actually 4.47 when you type it in, but to round to that nearest tenth, it rounds up to 4.5. And then for number 4, again, I don't know the hypotenuse, so I don't know C. I'm going to put those in. I've got 10 squared plus 11 squared equals C squared. Okay, 10 squared we know is 100. 11 squared we know is 121. And that equals C squared. And when I add those together, I get 221 equals c squared. And I'm going to take the square root of both sides. So I take the square root of 221. I get 14.86, so I'm going to round that up to 14.9. Round to the nearest tenth. All right. For number 5 and 6, we're trying to see if these form a right triangle. Now, if they form a right triangle, then the Pythagorean theorem will work. If they are not a right triangle, the Pythagorean theorem will not work. The Pythagorean theorem only works for right triangles. So I'm going to put these in for A, B, and C. So first thing I like to do is label my sides and then put those into the Pythagorean theorem. In fact, while I'm at it, let's go ahead and label number 6 as well. So I know which one is A, I know which one is B, I know which one is C. At the top of our paper, we wrote down the Pythagorean theorem. Let's plug it in. If A is 9.1, I've got 9.1 squared. If B is 6, I've got plus 6 squared. And if C is 10.7, I have all of that equal to 10.7 squared. Now let's check. Okay, 9.1 squared. Type that into the calculator real quick. We get 82.81. Okay. 6 squared we know is 36. And then 10.7 squared, type that one in. 10.7 squared gives me 114.49. And now let's see what 82.81 plus 36 adds up to. So 82.81 plus 36 is 118.81. Set that equal to 114.49. And then I need to put a little not equal to sign in between those. Those aren't the same amount. They do not equal each other. Okay, so this is not a right triangle. And I could have known that a little earlier on, right? If I see my decimal number ending in 0.49 on the right side, and then I know it's going to end in a 0.81 on the left side, they're not going to equal each other, okay? All right, for number 6, same thing. We already have it all labeled, so let's put it into the Pythagorean theorem. I've got 7.2 squared plus 6.5 squared equals 9.7 squared. And then let's see what those are. If I do 7.2 squared, I've got 51.84. If I do 6.5 squared or 6.5 squared, that's 42.25. And last but not least, if I do 9.7 squared, I get 94.09. Well, this might work. Look at our decimals. But let's go ahead and add them and see what we get. So I've got 51.84 plus 42.25. And that equals 94.09. Well, would you look at that? That's what's on the other side, right? So I've got the two things do equal each other. I can put a little check mark there. That is true. They do equal each other. So yes, this is a right triangle. A little exclamation point there because I'm excited that it worked out. All right, on the next page of our review, now we're going to switch gears just for a second and use the distance formula. Remember, the distance formula is derived from the Pythagorean theorem, so it's still covering the same thing. It's just a different way to use it. So I've got these ordered pairs. I'm just going to label them real quick. This is x1, maybe 1. This is y1. This is x2, and this is y2. Okay, I'm going to do that for number 8 as well. x1, y1, x2, y2. Now, why did I do that? Just so that when I plug this into the distance formula, it helps know where those numbers go. The distance formula, again, is d equals, we got a big long square root symbol, and we have in parentheses x2 minus x1, and that's being squared. Whoops, move that up a little bit. Let's move that back down. Plus y2 minus y1 in parentheses, and that amount is being squared. So seeing that, I'm just going to plug these in. Okay, for number 7, let's see, big long square root symbol, and then x2 minus x1. So x2 is negative 7, minus x1 is 5, and that amount's being squared. Plus y2 is negative 1, minus y1, which is 4, and that amount's being squared. Okay, now let's simplify. Just follow order of operations. Do what's inside the parentheses first. I've got negative 7 minus 5. Well, negative 7 minus 5 is negative 12. So I've got negative 12 being squared now. Plus negative 1 minus 4. Well, negative 1 minus 4 is negative 5. I'm more negative, just like I was for the x's. And that amount's being squared. Okay? Be careful with this. We talked about this in class. When you square a negative on your calculator, unless you use parentheses, it's going to tell you the answer is negative. We know it's not. We know it's positive. We know a negative multiplied by itself is positive. Okay, so negative 12 squared is a positive 144. Okay, negative 5 squared, that's a positive 25. All right, and then 144 plus 25, that's my last simplifying thing I got to do. 144 plus 25 is 169. The square root of 169 is 13. 169 was one of our perfect squares. Okay. I'm going to do the same thing for number 8. Big long square root symbol. Okay, that's what's going to be equal my distance formula. I've got x2 minus x1. So I've got negative 2 minus negative 8 being squared. And then y2 minus y1. So plus y2 is negative 1 minus negative 3, and that's being squared. Okay. Remember, subtracting a negative, same thing as adding a positive. So this is really negative 2 plus 8. Negative 2 plus 8 is 6. And then this is negative 1 minus negative 3. That's really negative 1 plus 3, and that's positive 2. And those numbers are being squared. Well, 6 squared we know is 36. 2 squared we know is 4. Mine went blank for a second there. 36 plus 4 is 40. So I've got this radical 40 as my answer. Notice my directions don't say to round it to the nearest tenth. So I am going to simplify this radical. Okay? I know the biggest perfect square. This problem should look familiar if you think back to earlier this week. Okay? I know the biggest perfect square that goes into 40 is 4. So I've got radical 4 times radical 10. Well, the square root of 4 is 2. And the radical 10, he just comes down. It's just radical 10. So 2 radical 10 is our answer there. All right. If you rounded that to the nearest tenth, well, I guess I should probably plug it in to make sure I do it right. The square root of 40 is 6.32. So rounding it to the nearest tenth, that would just be 6.3. Okay. For 9 and 10, we want you to come up with a Pythagorean triple. That's what this is called when you have 3 sides of a triangle that do make a right angle. That is a right triangle. Okay. The most common one, we talked about this is what carpenters will use, or construction workers will use. The most common one is 3, 4, 5. So 3, 4, 5, that does work, and I just want to show you that it works. If I do 3 squared plus 4 squared equals 5 squared, if I plug this into the Pythagorean theorem, it will be true. Okay, 3 squared we know is 9, 4 squared we know is 16, 5 squared we know is 25. Well, 9 plus 16, is not going to start with a 1. 9 plus 16 is 25. Okay, so there's one answer. And I'm not going to finish this. I want you to come up with a different one. I want you to come up with a separate one for number 10 here. Okay, so make sure that it works for a squared plus b squared equals c squared. And I want you to come up with one on your own. I gave you one. You come up with the other. If you have any questions about any of this, make sure you ask your teacher.